This time, the graphs of two functions fx and gx are shown below. And you are defining px as the product of the two functions, qx as the quotient of the two functions, and rx as the composition of two functions. Alright, and we have to compute p prime 3, q prime negative 2, and g prime 0. Let's think about p prime of 3. What's p prime of 3? That means you have to differentiate fx times gx, and then after differentiating you have to plug in 3 into it. Okay. Since it's a product, you have to use the product rule, so it's f prime of x gx plus fx times g prime of x. And then you're plugging in 3, so you have f prime of 3 g of 3 plus f of 3 g prime of 3. Okay, in order to get an answer for this, we really need the value of f prime 3, g3, and all that. Let's look at the graph and see what we have. What is f prime of 3? F prime of 3 is the slope at 3, and using rise over run, you see that the slope is 1 here. So m is like 1 in here. How about here? This is, you go down by 2 and right by 1, so the rise over run is negative 2 over 1. The slope is negative 2 here. Here, rise is 1 and run is 2, so rise over run gives you 1 over 2. That's your slope on this side. Whereas on this side, again, it's we're going down by 2 and going right by 1, so slope is negative 2 here. Alright, so f prime of 3 requires the slope at 3, so the slope is 1. What's g of 3? G of 3 is not the slope at 3, it's actually the value of the function g at 3. So at 3, if you look at the height, it's 1, so g of 3 is 1. What about f of 3? F of 3 is 2, and g prime of 3 is the slope at 3, and that is negative 3. Okay, so we have negative 2, sorry. G prime of 3 is negative 2. So you end up with 1 minus 4 equals to negative 3. So negative 3 is the answer for A. Let's try B. So it's a similar story. You have to differentiate this and plug in negative 2. So you need f prime of negative 2, g of negative 2 minus g prime of negative 2 and f of negative 2 over the denominator squared. Alright, f prime of negative 2 is in this picture here at negative 2, the slope is negative 2. So we have that. G of negative 2, the value of the function g at negative 2 is 1. And g prime of negative 2, we already computed the slope here. Slope is 1/2. And then f of negative 2 is equal to 3 all over g of negative 2 squared, but g of negative 2 we know that it's 1, so it's 1 squared. So it's negative 2 minus 3 over 2, which is negative 7 over 2. Okay, for g prime of 0, let's see. Think about g prime of 0. Because r prime of 0, because r is f and g composed together, you're really trying to take this composition of the two functions, differentiate, and plug in x equal to 0, which gives you f prime of g of x, g prime of x. That's the chain rule, you all remember that. So when you plug in 0 into it, you get f prime of g of 0 times g prime of 0. Now what is g of 0? If we go back and look at the picture here, g of 0 is 2, and therefore if I replace g of 0 as 2, I get f prime of 2, and then I have to multiply g prime of 0. Okay, what is f prime at 2? F prime at 2 is this portion. Slope is 1, and g prime at 0 is over here. The slope is 1/2. So we have 1 times 1/2. Therefore, the answer is 1/2. That's how this question is solved. Okay. Suppose the graph of a velocity of a moving particle is shown below, like this, and it says the graph is not the graph of the position. A lot of times you're given the position with respect to time, but here it's actually the graph of the velocity with respect to the time. Furthermore, it says that the velocity is measured in meter per second, whereas the time is measured in seconds. Estimate the acceleration of the particle at time t equals to 2. Okay. What is acceleration? What's the relationship between acceleration and the velocity? Well, acceleration is the rate of change of the velocity. In other words, acceleration is velocity's derivative. And since derivative means the slope, you should really look at the slope of the velocity, this velocity at time t equals to 2. Well, it looks like it's a straight line going through 1, 1, 2, 2, and 3, 3. And what's the slope here? It's increasing by 1, and it's going up by 1 and going right by 1. So its rise over 1 is 1 over 1. Therefore, the acceleration is just 1. Now it says your answer should have correct units. If you're dividing meters per second by seconds, you will be getting 1 meters per square seconds. Okay. Another way to explain why this unit is like this is you're trying to differentiate the velocity with respect to time. That's your acceleration. Acceleration is the derivative of the velocity, but it's the rate of change of the velocity with respect to time. And because the velocity has a unit of meters per second and you're dividing by the seconds, if you just purely looked at the units, it's meters per second divided by s, and that's why you have meters per second squared. What is the velocity at time t equals to 5? Here's 5. Velocity value is 5,2, therefore the velocity is 2 meters per second, because that's the height. The graph itself is the velocity. Is the acceleration at time t equals to 5 positive or negative? At 5, is the speed increasing or decreasing? The speed is decreasing. Or the velocity is decreasing, which means the rate of change with respect to time is negative. And because acceleration is the rate of change of the velocity, we know that the acceleration is negative. So the correct answer is negative. Here we are given a piecewise function. Find the value of c that will make f of x continuous at x equals to -1. Okay, so let's think about this. First, if you want continuity, you need the limits to exist, and the limit has to be equal to the value at that function. Okay, so let's think about this. What is the limit of f of x when x is sent to, say, -1 plus? Say we only need to investigate the continuity at -1, because away from -1, these are just polynomials which we know are continuous. The only thing that we're not sure of is whether these two different graphs would be pasted well together, so it gives you an unbroken graph or something. And in order to make sure that does work, we first have to make sure that the limit from one side is same as the limit to the other side. Okay, what is the limit from -1 plus? Which one should we use in this case? Because -1 plus means it's slightly bigger than -1, we should be using this definition, x minus x squared, then, because that's the case when x is slightly bigger than -1. So you need limit x going to -1 plus of x minus x squared, and then we can plug in -1 here, so -1 minus -1 squared. And at this point, because it's not like dividing by 0 or anything, this -1 plus doesn't really mean anything. It just means it's getting closer and closer to -1 as much as possible. So we're really just doing -1 squared, just like this. That's -1 minus 1, which is -2. What is -1 plus? It's like a number that's like -0.9999. It's just slightly tiny bit bigger than -1. That's what it means. Alright, so that's the limit. Now, what's the limit x going to -1 minus then? In this case, because you're using the value slightly less than -1, we have to follow this condition. Cx minus 2, and then when you plug in -1, you get c times -1 minus 2, and that's -c minus 2. And for the limit going to -1 to exist, the left limit and right limit must agree, so -2 has to equal to c minus 2. What does that mean? C should be 0, right? So c equal to 0 is the answer for the first one. Okay. Now, if c is assigned a value that makes fx continuous to -1, in other words, if c is equal to 0, would it also be differentiable at x equals to -1? Well, so to investigate part B, we need to know that the limit of f of x we know that it's differentiable away from -1. The only thing that we're not sure of is whether it's differentiable at -1. So what is the derivative at -1? It's f of -1 plus h minus f of -1 divided by h, and where h is set to 0. Okay. Now for this limit to exist, again, the limit from 0 plus and 0 minus should agree. The left and right limit should agree. And those actually have a name. The name for those is that you have a left derivative and right derivative. The left derivative will be this limit with h going to 0 minus. The right limit will be this entire thing with, instead of 0, you would have 0 plus. If those two agree, then we know that this limit does exist. Now, when you think about it, the left derivative is actually the derivative of this function. So what is the left derivative at -1? So if you differentiate, then you're going to get c, or 1 minus 2x, right? And this thing, because this is the just before -1, this is the left derivative, 1 minus 2x is right derivative. And especially when you think about the derivative at -1, when x is equal to -1, this thing evaluates to 1 plus 2, so that's 3. And because c is equal to 0, this is just 0. And what that means is that if you actually computed this left derivative and the right derivative for c equal to 0, you will see that the left derivative will give you 0, while the right derivative is equal to 3. And since they do not agree, this limit doesn't exist. Therefore, the derivative is not defined, so it's not differentiable. Okay, to write this in a simpler way, you can just say this does not exist because slope before -1 is 0, right? Just before, and slope right after -1 is 3. So the left derivative is not the same as right derivative. So not differentiable. That's the answer. Find the equation of the tangent line. It's the graph y equals to x squared plus 2 squared. Okay. Where the point x is equal to ln of 2. So this is simply find the slope and use the point slope form. It's a very simple question. All right, so let's try to find the slope by differentiating. Since this entire thing is inside the square function, we need to use the chain rule. So 2 comes down, 2 minus 1 is 1. The inside function has to be pulled out, and you have to differentiate this. Derivative of e to the x is e to the x. Derivative of 2 is 0. Okay. And therefore, you get 2 times e to the x plus 2 times e to the x. That's your y prime. Now, what is the actual slope at x equal to ln of 2? This is not a slope because it varies. I mean, this is not a slope at a certain point because it varies with respect to x. In order to get the slope at a point, you still have to plug in the value of x. Okay, so beware not to use the derivative in general as the slope. Always you have to evaluate x at some point in order to use it as a slope for some line. Okay. All right, so you have, if you evaluate at x equal to ln of 2, you have 2 times e to the ln of 2 plus 2 e to the ln of 2, and because ln and e cancels, e and ln cancels, you end up with 2 times 2 times 2. Right? This is 2, that's, oh no, sorry. This is 2, that's 2, and there's another plus 2, right? So inside this parenthesis, there's 2 plus 2. So 2 times 2 plus 2, and this is again 2. So you end up with 4 times 2, 8. 8 times 2 is 16. So 16 is the slope. Now we have to plug that into the point slope form. But wait, in order to use the point slope form, we need both the x value and the y value. So we really need to evaluate the function y at x equals to ln of 2. What is that? That is e to the ln of 2 plus 2 squared. They cancel, and that's 2 plus 2, which is 4. 4 squared is 16. So actually, this is just pure coincidence. Y prime and y are both 16. Okay. This means the coordinates are ln of 2, comma 16. That's the point that the line passes through, and this is the slope. Now let's apply the point slope form. Y minus y naught, so this 16 is here, equals to the slope m, which is 16, and x minus ln of 2. Okay. So that's the equation of the tangent line in point slope form. Find all values of x where the graph is given like this. Where the graph of f given like this has a horizontal tangent. Okay, what does horizontal tangent mean? That means the tangent line is a horizontal line. That means the slope is equal to 0, because horizontal lines have slope 0. In other words, this question is just another way of saying find the x values where f prime of x equal to 0. That's what it's. So what should x be? That's basically the question. All right, let's differentiate. That's 6x squared plus 18 and minus 18x minus 16. And since all of these can be factored by 6, let's pull out the 6, factor out the 6. What's left is x squared plus 3x minus 10. Okay, this can be factored as x plus 5, x minus 2, and therefore when f prime of x is equal to 0, that means 6 times x plus 5, x minus 2 is equal to 0, and that means x is equal to negative 5, and or x is equal to 2. So those are the values of x where the function has a horizontal tangent. Find the derivative of this given function and use that to find the equation of the tangent line. Alright, since you have a fraction, you should be using the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay, this is just 1. Square root of x differentiates to 1 over 2 times square root of x over x. Okay, since I see fractions inside fraction, let's try to simplify this by multiplying 2 radical x top and bottom. So I'm multiplying 2 radical x to the first one, also 2 radical x to the second part of the top, in which case this thing will cancel away, and then also in the bottom I'm multiplying 2 square root of x to this x. Okay, and that's 2x, because square root of x squared is 2, and then minus 2, no, actually this entire thing cancels away, so minus distributed to x plus 2 is minus x minus 2 over 2x times square root of x, and that's equals to x minus 2 over 2x times square root of x. Okay, now that's part A. For part B, we need the slope, and you get the slope from the derivative by evaluating it. So f prime at 4 is equal to 4 plus 2, which is 6, divided by square root of 4, and that's 6 over 2, which is equal to 3. So slope is equal to 3. 4, 3 are the points. So using the point slope form, y minus 3 is equal to 3 times x minus 4. And this is the equation of the line. Implicit differentiation. Okay. Implicit differentiation means to find the derivative of y with respect to x without actually solving for y, right? For example, this is a fifth order equation for y, so it's almost impossible. Actually, it could be impossible to solve for y. So in this case, we have no choice but to differentiate as it is. So in order to find y prime, we just have to differentiate both sides as it is. But when you're doing this, remember that this prime means d dx. You're differentiating by x, and although y is not x, y is actually a function of x. If you solved this for y, y will be a function of x, and therefore when you're differentiating, always remember that this is a function of x. Especially it's important when you're differentiating something like this. Although it looks like a simple function, it's a nested function because y is a function of x. It's a function of x that's nested inside the fifth order function. Okay, so first x cubed differentiates to 3x squared. Okay, and then minus 4, that's just the constant. We really have to differentiate x squared y. Let's leave it in this form for the moment. Okay, how about this one? Y to the fifth. As I said, this is a nested function, so you have to use the chain rule, which says you differentiate it as a function of y, but that inside function should be pulled out and differentiated, so y prime appears here. Now this is actually a good thing because we really want to find y prime. This is dy dx is just another way to say y prime. We're really trying to find y prime, and since it's here, then we can just solve for this y prime and we'll get the answer we want. Alright, back to this one. This y is a function of x, and you have a function of x which is x squared. You have product of two functions of x. What are you supposed to do? You have to use the product rule, right? So x squared prime y plus x squared times y prime and then x squared differentiates to 2x x squared y prime 5y fourth y prime, and this is 3x squared. If I multiply the negative 4 out, it's negative 8. 4 times 2 is 8 xy, and negative 4 times this is negative 4 x squared y prime equals to 5 y to the fourth y prime. Okay, so we've differentiated as much as we can, and we also see y primes appearing, which is what we want to know. This is not the answer. We still need to know what y prime is in terms of x and y. So let's try to solve this for y prime. How do you solve it? First, you add 4x squared y prime both sides, and the rule of the thumb is just look at each terms. How many terms do we have? 1, 2, 3, 4. We have 4 terms, and you can distinguish the terms by whether it has y prime or not. These two do not have y prime. This one does have y prime, and things that have y prime will belong together as a group, and those that do not should be in the other group. So if we leave the 3x squared minus 8xy on one side, and if we move 4x squared y prime on the other side, we're going to have 5y to the fourth y prime plus 4x squared y prime. And the reason that we want to do this is because once you do it, then you can factor the y prime out. And whatever you get is something that you can divide with. Let me rewrite this again. It's something that you can divide with. 4x squared equals to 3x squared minus 8xy. So if I divide both sides by this thing, I end up with y prime equals to 3x squared minus 8xy over 5y to the fourth plus 4x squared. So that's the final answer. This is the answer that you want to write down. Okay, let's move on to the next example. Tangent y over x equals to x squared minus y squared. Okay, again, you want to differentiate both sides. So I have tangent on one side, I have to differentiate that. X squared minus y squared should be differentiated also. Tangent differentiates to secant squared y over x, and because y over x is an inside function, you have to pull the inside function out and differentiate. Here x squared differentiates to 2x, and y squared, remember y is a function of x, which is nested inside the square function. That means you have to use the chain rule, so it's 2y, and y has to be pulled out and differentiate. It should be differentiated. Okay, now let's think about this one. It's a fraction, and y is a function of x over x. So it's a ratio of two functions of x, which means we have to use the quotient rule. So let's use the quotient rule. Top prime times the bottom minus bottom prime times the top over the bottom squared equals to 2x minus 2y y prime. Okay, now this y over x, this x in the denominator, you can't do anything because it's enclosed by this secant squared function. So you can't really simplify this one. But before I try to solve for y prime, I wish to get rid of the denominators as much as possible. And I see this x squared. That can be cancelled if I multiply x squared both sides. So let's do that. I'm multiplying x squared. And when this x squared, that cancels with that x squared. And then once I multiply these two, I have the following. I end up with secant squared y over x times y prime of x. Okay. Y prime is good. This is what we are going after. And then secant squared y over x times x prime y. But what is x prime? That's just 1, right? So it's really times y. Because this is just 1 that doesn't have to be written. If you really want, you can put 1 times y. But let's not do that, okay? And this one, if I multiply x squared, is 2x cubed and minus 2x squared y prime. Okay. Again, you have 4 terms. And I see that the very first one and the last one, those are the ones with y prime, and these two in the middle do not have y primes in there. So these two belong together. These two in the end should belong together. Let's regroup them by moving this over here and moving that over there. Okay. So if I add this term both sides, this is going to appear on the left side as a positive. So you're going to get secant squared y over x times x times y prime plus 2x squared y prime equals to secant squared y over x times y plus 2x cubed. Okay. Now, since I have y prime, I can factor out the y prime. If I factor out the y prime, let's see what's left. I have x times secant squared y over x. And then in here I have 2x squared y equal to secant squared y over x y plus 2x cubed. Okay. And then since I need to isolate y prime, this entire thing must go, and you can get rid of this by dividing to the other side. Alright, so final answer is, let me write in green, the final answer is y prime is equal to, oh, it's very confusing. It's secant squared y over x times y plus 2x cubed. And then I have to divide this entire thing by x times secant squared y over x plus 2x squared y. Okay, so it's the ratio of this divided by that. That was a really challenging question. All right. Let's try e to the 2xy equals to x cosine 2y. Differentiate both sides. And 2xy is inside, so you need to use the chain rule. This one requires a product rule because it's a product of two functions. Alright, this one is again product of two functions, so let's apply the chain rule. 2x prime y plus 2x y prime. x prime is 1, and cosine 2i, by the chain rule, cosine differentiates to negative sign, but the inside function has to be pulled out and differentiated. If you differentiate 2y, you get 2y prime. Alright, let's multiply this out. Now 2x prime is 2, so it's 2y times this, so it's 2y e to the 2xy. If I multiply this with this, I get plus 2xy prime e to the 2xy equals to cosine 2y, and then minus x sine 2y, and then 2y prime. Let's move this 2 here. Okay. Alright, again we see some terms. These two have y prime, these two don't. Let's move this over here and move that to the other side. What do I get then? I get 2xy prime e to the 2xy plus 2x sine 2y y prime equals, on the other side, since I'm moving this to the other side, you get cosine 2y minus 2y e to 2xy. Okay, and then if I factor the y prime and divide by the parentheses I create by factoring this out, I get y prime as cosine 2y minus 2y e to the 2xy divided by 2x e to the 2xy plus 2x sine 2y. So that will be the answer. Okay, very rarely you can simplify the given equation before you try to differentiate implicitly. A lot of times when you see exponential functions or sine, it's really tough. If you have secants or cotangents, those reciprocal functions, maybe it's worth a try trying to rewrite it as a fraction and then simplifying. But here we have fraction equals to a number. In that case, I can multiply 2xy both sides to get rid of both the denominators, right? So that certainly is going to simplify the equation, and it'll be much easier to differentiate afterwards. Okay, so I have x over 2y plus y over 2x, and I'm going to multiply 2xy, and also 5, and I'm going to multiply 2xy. So I'm copying the above equation, but then I'm multiplying 2xy both sides. Now, if I multiply 2xy to the first thing, 2 and 2 will cancel, and y will cancel, and I'm going to get x squared. If I multiply 2xy to the second thing, the 2x and 2x will cancel, and you're going to get y squared. 5 times 2 is 10. So you end up with x squared plus y squared equals to 10xy. Okay, I think this is much simpler than before. Now let's differentiate both sides. After all, this is implicit differentiation, so we have to differentiate both sides, which creates 2x plus 2y prime. This is 10y plus 10xy prime, because I'm using the product rule here. So it's 10x times y, and if I differentiate 10x, I get 10, and if I differentiate y, I get y prime. Okay, again, move to one side. So let's make 10y go this way. So it's 2x minus 10y, and 2y prime to the other side. So it's 10xy prime minus 2y prime. factor the y prime, so we get 10x minus 2y y prime equal to 2x minus 10y, and you divide, so you get y prime equals to 2x minus 10y, 10x minus 2y. Okay. If you want to simplify this further, you can divide top and bottom by 2 because everything you see here is even, so you can rewrite it as x minus 5y over 5x minus y. Okay, logarithmic differentiation. Logarithmic differentiation is especially important when you have a bunch of fractions with some rational powers. Okay, so the method is to introduce the y that wasn't there before, and then we will try to find y prime, right? Okay, but why is this called logarithmic differentiation? It's because before you take the derivative of both sides, we're going to take log of both sides. So it's ln of y equals to ln of this crazy fraction, x plus 1 to the 5th power, and then over x squared plus 1 squared x plus 2 thirds. Okay, why is that good? What help does that give? Well, here is why it's so good. Log has some great rules which can deal with division, multiplication, and powers. So first of all, you see this division here that can be written again as a difference. Okay, and then you can rewrite this as 5 over 2 because square root is 1/2 power, and 5 over 2, that's an exponent instead of the log, which can jump over the log. So I have 5 over 2 ln x plus 1, and this is a multiplication, so I can rewrite that as addition. Plus ln of x plus 2 2/3, and again these numbers can jump over the log. So if I distribute the minus sign, let the numbers jump and all that, I end up with 2 ln x squared plus 1, and then because of this minus, this should be minus. 2/3 comes front, ln x plus 2. Okay. So don't forget to distribute the minus signs. So this is what I get after taking the log both sides and then trying to simplify as much as you can using the log rules. This is what I get. Now we differentiate both sides. Okay, y is a function of x, so if you differentiate, you have to use the chain rule. Derivative of log of y is 1 over y, and then pull the y aside and you differentiate. So that's what you get on the left side, or y prime over y. You can just memorize that log of y differentiates to y prime over y. On the right side, log of x plus 1 differentiates to 1 over 1 over x plus 1, and then 2, 1 over x squared plus 1. Now, sorry, you have to remember that x plus 1 is a nested function, so it has to be pulled out and differentiated. But what's the derivative of x plus 1? It's just 1, so there's nothing to multiply here. However, here, if I pull it out and differentiate, it creates 2x. So there is something to multiply. This one, again, it's minus 2/3, 1 over x plus 2, and when you pull the x plus 2 out and differentiate, it's just 1. So this is what I get. And we're almost done. We need to multiply the y to the other side. And the thing is, y is something that we introduced. So we can't leave that in the final answer. So we have to go back and see what y was. Y is this horrible thing, right? So I should be rewriting that y here. So if I multiply y to the other side, it's a square root of x plus 1 to the 5th power over x squared plus 1 to the squared and x plus 2 to the 2/3 power. That's your y. That's multiplied to this entire thing, which is 5 over 2x plus 1 minus 2 times 2 is 4. So 4x over x squared plus 1 minus 2 over 3 times x plus 2. Okay, and that's it. This is everything. Okay. So that's how you differentiate using the logarithmic differentiation. Now, this looks confusing, but actually if you try to differentiate this without using the logarithmic differentiation, that's impossible. This is still doable. So this is better than the other the straightforward approach in this case. Okay. Now another handy case where you can use logarithmic differentiation is when you have a function of x to power of another function of x. Now this is something it's really hard to think about any way to solve this without logarithmic differentiation. Although there is one, it's really hard to think. Okay, so let's try this. Introduce y. And then take the log both sides. And since 3 sine x is an exponent inside the log that can hop over, now I can differentiate both sides, so it's y prime over y. This is a product of two functions, so I need to use the product rule. Sine x differentiates to cosine x, and then 3 sine x. Log of x differentiates to 1 over x. Okay. And then finally you multiply by y, but remember y is this thing, x to 3 sine x, that's the original one, so therefore the answer is y prime is x to the 3 sine x multiplied by this entire thing, 3 cosine x ln of x plus 3 sine x over x. Okay, this question is about finding the tangent line. The difference is that this time you're given the equation implicitly, so when you find the slope, you can't just solve for y and differentiate. You actually have to use implicit differentiation to find the slope. So let's do that. Let's differentiate both sides using implicit differentiation. Differentiate this, differentiate 13. 13 is a constant, so if you differentiate, you're going to get 0. Whereas x squared differentiates to 2x. xy, you need the product rule, so let's write it like this for the moment. And y cubed, that's chain rule, 3y squared, and then y pulls out, and you have to do y prime. Now if we apply the product rule, it's x prime y plus xy prime, so that you have x prime is 1, and negative 2 times 1y is negative 2y, and then negative 2 times xy prime is minus 2xy prime, minus 3 y squared y prime equals to 0. Okay, now we have to move to one side all the y primes. So here's the term with y prime, it moved over the other side, so minus became plus. This one also have to move to the other side, so it's plus, and then you factor the y prime out. So that when you divide this to the other side, you end up with a y prime equal to 2x minus 2y over 2x plus 3y squared. Okay, now we can plug in negative 3 comma 2 into this function, and it means that x should be negative 3, and whenever you see y, it should be replaced by 2. So it's 2 times negative 3 minus 2 times 2, 2 times negative 3 plus 3 times 2 squared. Okay, that's negative 6 minus 4, that's negative 10 in the top. This is negative 6, and this is 3 times 4, that's 12. 12 minus 6 is 6. So you get the slope as negative 5 over 3. And then, since you're given the point, your final answer is just the point slope form, y minus 2 equals to negative 5 over 3, x minus negative 3, so it's x plus 3. So that is the equation of the line. Okay, find 2 points on the graph of this thing which intersects with the vertical line x equals to negative 1. Okay. Alright, so we're trying to find where this meets x equals to negative 1. That means we need to find the value of y, because after all, anything that's on this x equals to negative 1 line will have the x coordinates as negative 1, right? So I don't know the graph of this, but let's just say it's some kind of a strange graph or something, and then it meets here and there. And then what you're really looking for is just the value of y, because you already know the x value. Alright, so what kind of equation should the y value satisfy? Well, it should satisfy that if x is equal to negative 1, it should satisfy this equation. So you have negative 1 cubed plus 2 times negative 1y plus 3y squared equal to 0. And then negative 1 minus 2y plus 3y squared equal to 0. And then 3y, okay, so I need to factor this. Let's see, how does this factor? 3y minus 1 and y plus 1 maybe? Let's see. 3y times y does give you 3y squared. Negative 1 times 1 does give you negative 1, but if I multiply this and add, oh, actually it should be, this one should be positive and that should be minus. Okay, so you probably know other ways to factor this. There's also another way called factor by grouping, but whatever method you use, you should be able to factor it and set it equal to 0 to find the two values. If everything fails, you still have the quadratic formula, right? Negative b plus minus square root of b squared minus 4ac over 2a. Since you have that as a backup, if everything fails, you can use this to find the two values. but luckily I was able to factor it, and that says the values of y is -1/3 and also 1. Okay. Now here it says at each point evaluate y prime. So I have to find y prime. In order to find y prime, I have to again differentiate this implicitly. So let's differentiate that implicitly. If I differentiate x cubed, that's 3x squared. If I differentiate 2xy, I need the product rule, so it's actually 2x prime y plus 2xy prime. And then 3y squared, that requires chain rule. 2 comes down and you get 6y, but then you also have y prime equal to 0. Alright, this is just 3x squared plus 2y, and those don't have any y prime, so that's okay. And I have to move these to the other side, so it's -2x y prime minus 6y y prime. And factoring out the y prime and dividing, I end up with y prime being equals to 3x squared plus 2y over -2x minus 6y. Okay. And then if I go back and question what we're doing, at each point I have to evaluate this y prime. So I have to evaluate this for y prime when x is -1 and y is -1/3. So in this case, what would we have? So if x is -1, that will just be 3. -1/3 will give you -2/3. This is +2. And -1/3 times -6 is again +2. So you get 7/3 divided by 4. So 7/12 is what you get for this point. And then y prime, when you evaluate at -1, 1, I plug in -1 here, still get 3 and 2. But if y is 2, I get +2. And then -6, so in that case I get -5/4. Okay, so those are the two answers, 7/12 and -5/4. Okay, sketch a function where you're given these values and it satisfies inequalities. F prime is less than 0 for x less than 2. F prime is positive for x greater than 2. Okay. So let's think about what's going on at 2. We know that if I plug in 2, so let's say 1, 2, the function value is 3, so the graph should be passing through this point. Okay. However, f prime of 2 is equal to 0. That means I have a horizontal tangent line here. Now, when would you have a horizontal tangent line? It could be like this one or that one. It could be like briefly 0 and coming down. That's another special way that could be still having derivative equal to 0. However, we have f prime less than 0 for before 2. So what does that mean? F prime less than 0 means that the graph has to be decreasing, right? It should have a negative slope. So we know that the left side before 2 should be like that. And since after 2 the derivative is positive, it has to have a positive slope, so it must be like this. So we know that before and after 2 the graph should be this way. Okay, since that's messy, so let me draw this again. The graph should be like 2 and 3 here. Here's the point, and it should be like that. Let me erase this. That should be an example of a graph. Now we don't know if it's like going really steeply up, or maybe it's like that. That we don't know. There's not enough information to determine which one is which, but we generally know that it should be of this shape. Now the second question is, should this function be continuous? Why or why not? The answer is yes. If you want to draw an example of such a thing, you need the graph to be continuous, because what these conditions implicitly tell us is that the value of the derivative exists for all real values, right? So f prime is negative. It means that f prime does exist for any value of x less than 2. This also means f prime does exist for any value bigger than 2. And f prime does exist, its value is 0 at 2. So it's differentiable everywhere. What does differentiable everywhere mean? It means it's smoothly varying, so that you don't have like a corner, a sharp corner. Because if it's like this, then it's not going to be differentiable. So if it's differentiable, we actually know that it's continuous. So this is something that we learned. Differentiability implies that it's continuous. The contrapositive of this statement is also important. This statement is equivalent to saying that if you have a non-continuous point, then at that point it shouldn't be differentiable. So if you have like a jump discontinuity or like a removable discontinuity, at all those points it's not differentiable. Okay. So the answer to B, you should say yes, it should be continuous because it is differentiable. Okay. If it's differentiable, we know that it's continuous. That's how you argue. Suppose particle is going on a straight line. Its position at time t is given as some function like this. Find the velocity for all time t. So let's try this. Velocity is the derivative of the position. So if I differentiate, vt is derivative of xt, and that's 9t squared minus 12 plus 0, because if you differentiate 5, it's 0. So 9t squared minus 12 is the velocity. What's the acceleration? Acceleration is the derivative of the velocity, right? So that's 18t, and this minus 12 is just a constant, so if you differentiate that, it's 0. Now, therefore, a of 2, the acceleration at time t equals to 2, is 36. So that's the answer to B. That's the answer to A. Find the average velocity from t equals to 1 to t equals to 4. Okay. What is the average velocity? That's the position, final position minus the initial position, and final time minus the initial time. Okay. Now, rather than trying to memorize this complicated formula, you should really think of this as change of x, change of the position over change of time. That's the average velocity. Okay. All right. So what is this? V bar is final position. Well, you have to know what x of 4 is. Well, let's write x4 for now. Okay. So we have to know where the position of the particle is at time t equals to 4. And also time t equals to 1, we have to know the position divided by final time is 4 minus the initial time 1. Okay. X of 4 cubed is 64 times 3, 128, 64, 192 minus 12 times 4, so that's minus 48. Plus 5 minus, if I plug in 1, that's let's see, 3 minus 12 plus 5 over 3, and then see this 5 and 5 cancels, and then this is minus 9, that's plus 9. Okay, and therefore, let's see, 192 plus 9, 39. Okay, well, let's just do this. Minus 48, that's 4, 144, and then if you subtract 9, that's 5, 135. Okay, so you have 135 divided by 3, which is 4 times 12, 15, 45. Okay, so that's the average velocity. Okay, at t equals to 2, is the particle moving left or right? Now, let me write this d. What is v at 2? If I plug in 2 here, that's 4 times 9, that's 36, minus 12, so that's 24. Okay, if the velocity is 24, is it moving right or left? Actually, the value is not too important. What's important is whether this is plus or negative. If it's negative, then you're moving left because the position is decreasing. If it's positive, then it's... Find the point in the first quadrant on the lemniscate, this, where the tangent is horizontal. Okay, again, you're given an equation where it is not solved with respect to y. So in order to discuss horizontal tangent, which means that the derivative is equal to 0, you really have to differentiate this implicitly. So let's try to differentiate this implicitly. So let's see, 2x squared plus y squared equals to 25 x squared plus y squared, and I have to differentiate both sides, and that gives me 2 comes down. This is the chain rule because I have something complicated. That's inside function, and the squared is the outside function, so I have to use the chain rule to bring the 2 down. It's 4 x squared plus y squared. This inside function has to be pulled out, and it has to be differentiated. And on this side, differentiating x squared gives you 2x. Differentiating y squared, again, that's the chain rule. It gives you 2y prime. This y prime is the inside function's derivative. Okay, this one, that's again exactly the same thing as I did over here. So it's 4x squared plus y squared times 2x plus 2y prime. Okay, I could proceed as what I've been doing before, expand everything, isolate the terms with y prime, and solve for y prime. However, let's just take a shortcut. If we want horizontal tangent, that means y prime is equal to 0. And since we're only trying to figure out for what x and y values y prime is equal to 0, let's just plug in y prime equal to 0 and look for the x, y values. Okay? So if I plug in y prime equal to 0, I get 4x squared plus y squared times 2x, and this will be, if y prime is 0, I'll get 2 times 25, which is 50 times x. Okay, and then if I move the 50x to the other side, I get 4x squared plus y squared times 2x minus 50x, and I see that they both have x, and they also have 2 as the common factor. So these two terms, from these two terms, I can factor the 2x out. If I factor the 2x out, I end up with 4 times x squared plus y squared minus 25 times 2x equal to 0. Okay. So I end up with this condition for y prime to be equal to 0, but since we need x and y, I actually need 2 equations. See, x and y are unknowns. I have one equation for 2 unknowns. That's not good. I need another equation. And if you look back, you see that this equation that you were given before, that has to be satisfied also for a point to be on this curve. So we actually have one equation, another equation. So we have 2 equations. Alright, Now, what can we find out from here? This one, for this to be 0, either 2x has to be 0, which case is x equal to 0, or this thing has to be 0. If for this to be 0, 4x squared plus y squared minus 25, for this to be 0, I can solve, for this to be 0 equal to 0, I can solve this for x squared plus y squared and get x squared plus y squared is 25 over 4. So those are the two cases. And I have to figure out what happens in each of those two cases. See, I have already made use of this equation to get these two conditions. Therefore, I just have to use these two and also the given equation. So let's go back to, I copied the question one more time because it's a long question. So let's think about the two cases. So I have two cases. One is when x is equal to 0. Another is when x squared plus y squared is equal to 25 over 4. In both cases, what I'm looking for is both the x and y values, and I need this equation to be satisfied as well as these two separate cases. So this is case 1, that's case 2. Okay, let's go further. If x is equal to 0, I get 2 times 0 plus y squared equals to 25 0 plus y squared. Okay, so this is 2y to the 4th equal to 25 y squared. Now move this to the other side, so you get 2y to the 4th minus 25 y squared equal to 0. And if I factor the y squared, I end up with 2y squared minus 25 equal to 0. So this can only happen either when y is 0 or when this is 0. When is this 0? That's when y squared is equal to 25 over 2, which means y is 5 over square root of 2. And if I rationalize the denominator, it's 5 radical 2 over 2. And by the way, whenever you take the square root both sides to solve an equation, make sure you put plus or minus. So you actually have 3 cases here. So this actually means it's 0, 0. See, x is 0, so x is always 0. So it's 0, 0, or 0, 5 radical 2 over 2, or 0, negative 5 radical 2 over 2. All these points satisfy the original Logarithmic equation. I don't know what the graph of this is, but I definitely know that these are the points on here where you have horizontal tangents. Okay, what about this one? For this case, since I have x squared plus y squared here and x squared plus y squared here, why not just replace them? So I need 25 over 4 squared to this thing, and also 25 times 25 over 4. I need this equation to be satisfied. Now this actually looks quite fishy. Is this actually true? Can this hold? So 25 squared is 625 over 4, and this is 625. Actually, 4 squared is 16, sorry. 16. And this right side is 625 over 4. And even after factoring this out, it's 625 divided by 8 on the left side, 625 over 4 on the right side, and these are not equal. That means this can't work. Can't work. Okay. In other words, there's no way that both of these conditions can be true. X squared plus y squared equal, if this is equal to 25 over 4, then it can't be, this can't be true. So that's something that we see. Therefore, our final conclusion is that these 3 points are the only points where the original equation has 3. These 3 points are the only points where the original equation has horizontal tangent lines.